later tonight. We'll see. All right, here we go. Hopefully you recall some of our discussion about the concept of particle motion from Unit 4. Now that we have added the ability of using integration to our toolbox, we can do so much more with this idea. Recall that in our study of particle motion, a particle moves along a horizontal line so that its position at time t, where t is greater than or equal to 0, is given by s of t, or also oftentimes x of t. Velocity is v of t, and acceleration is a of t. So I'm going to give you about a minute or so, and I want you to try this little think about it problem. It says your teacher moves along a straight line at the front of this classroom according to the values in the table below. T is measured in seconds, and x of t is measured in carpet squares. So at time t is 0, your teacher is standing 2 carpet squares to the right. Okay? So go ahead and answer 1 and 2 based on this information. All right, discuss at your table. 30 seconds. What'd you get?
24. Yep. Yeah, I got 16 for 1.
All right, number 1. Elizabeth, what did your table say? Yep. 16 carpet squares. And Michael, how did your table do that? How did you come up with 16? How did you figure it out? Oh, you didn't get 16. Okay. All right, Kai, did your table get 16? Oh, okay. So how far from your teacher's ending position from the starting position? So you're 2 to the right, and then you land at 18. Like, even though the teacher has moved back and forth, all you do is ending position minus starting position. All right, number 2. Stephen, what did your table say for what is the distance your teacher traveled from t equals 0 to t equals 4 seconds? Good job. 24 carpet squares. All right, Jackson, did your table get 24? Okay, how would you come up with the 24 then? Oh, okay. Ella, did you get there?
Yeah, we just added like all the positive values and subtracted
The negative. Okay. So when you're talking about the distance traveled, I mean, think about when you're in a car. Like, you can go forward in your car, and you can also go in reverse in your car, and the car's odometer still reads distance. So going in the negative, so that minus 2 is telling me, giving me the direction where I am. So from Or like this. So from 2, and then 2 to negative 2 is 4 units. That's 2 units, 2 units, and 16 units. Could you look at it like that? That works too. All right, so we'll dive into this a little more for those of you that might be a little bit still confused about it. In example 1, my target today is to get through example 2, get halfway with a shortened period. So example 1 says particle motion with technology. So grab your graphing calculators if you don't have them out. A particle moves along a horizontal line. For time between 0 and 8, the velocity is given by v of t, and the position is given by s of t. It is known that s of 0 equals negative 3. So let's use our highlighters. That's going to be important. Part A says find all the values of t in the interval from t is 4 to 7, for which the speed of the particle is 5. Well, do you remember that speed is the absolute value of the velocity? So what I want you to do is go to your graphing calculators, and I want you to graph the absolute value of v of t and graph y equals 5 and find the points of intersection. Let me repeat that. On your graphing calculator, you're going to graph 2 things. Now you would need to either store or define v of t. Remember we went over how to store this? I would probably do that because it's so complicated. I would probably go define it, then go to my graphing calculator, and then do graph absolute value v of t, graph y equals 5, and look for the points of intersection. If you don't have a graphing calculator with you today, I have 2 or 3, actually 3 of them back on my charging station. You can borrow one if you put your cell phone in the slot, because I'd like you, if you don't have your calculator, to still use one and practice. If you need any help using the graphing calculator, let somebody at your table know. If they can't help you, then raise your hand and I'll help you. But typically another student explains it really well. Yeah. Oh, okay. So what you're going to do, you need to be on a calculator page. No, so you're going to press menu, and number 1 is action, and you define, and then I would type in literally v of t equals, so there's your equal button. You type it in, and then when you're on the graphing page, you type v of t.
Oh, that's easy.
That's it. Yeah. Well, we need absolute graphing, yes. All right, for those of you that forgot, if you want to store v of t, you have to open a blank page, and you press menu, number 1 is define, and you put v of t equals, you have an equals button there on the left column. Let me see if I can't. All right, you getting it? Like, are you able to get the intersections?
Well,
Yeah.
my window, like I turned the fan and the window's just not
Oh, check your mode. You need to be in radian mode. You are in radian mode. Okay. Okay, so let's press menu number 4. And let's try to maybe zoom out. I don't see your second.
Yeah, I
Can
know.
you find it?
This?
Yeah.
Well, I didn't.
Yeah,
I
it's not in
just
the
typed
range that we need.
Okay, where is it?
Yeah, I didn't know. Like this is like that.
Yeah, I see the one, but I don't see the, you put them on the same grid.
6-2.
In tabs.
Yeah. If you don't include the multiplication between the x and the sign, then it
Yeah,
gives it
mine
something
only
else.
has 6-2.
So you need to include the multiplication between the x and the sign.
Okay, terrific. So between the two t or your two x, you need a time sign here?
Yeah,
Okay.
otherwise it thinks it's
Oh,
some,
I
it's
forgot.
an equation of or you're defining something else less than.
Okay. All right, did everybody hear what Logan said? Be careful when, and this would be true, I believe, if you're defining it as well as if you're going to straight enter it. You have to have a time sign between the two t after that t and the sign function, because the calculator doesn't understand what to do. So as you can see, navigating the calculator is a huge piece, and I've tried to be patient to let you kind of figure this out. I got two places. I got t is 5.621, and I think this was, it doesn't say the time units. Typically it's seconds. And then I got t was 6.520. Yeah.
So on my calculator, there's like a slider for like where t should be.
Uh-huh.
So like, how do I? Because the way it is right now, it's not like on it. And then if I go to t0, then that it's just right.
Well, see, I think your issue is you define letter T, you're putting it on a graph with X. So I think you go back to define, and can you
Am I able to like
change it to the letter X?
Oh, and I had x squared over 12.
Oh, that might be the issue. Yeah. All right, questions? Are we getting it?
Yeah, if you should replace it with t.
All right, letter B. Let's move on, and we can definitely work on the calculator buttons. We have a few days before our quiz on Tuesday. Letter B, write an expression involving an integral that gives the position. So now we're going to connect this. The position is going to be, and remember we used our green highlighter here, the initial position, s of 0, is -3. So I need -3 plus, then I'm going to have the integral from 0 to t of v of, now I can't do v of t again, I have to use a different variable because then you're going to plug in t in the x position. Then it says use this expression to find the position at time is 3. Then if you have defined v of t or v of x, whichever letter you use, now this will be easier because remember the integral from 0 to 3 velocity just tells me the change in position. It doesn't tell me that location. So I have to have that -3 out front. So let's go ahead and make sure we can use our calculators here. And again, this is a bummer. I don't see any units in the problem. So I can't put units if I don't have the units. Letter C, find all the times t in the interval from 0 to 8 at which the particle changes direction. Well, the particle changes directions. How do we know when it changes directions? Anybody remember from chapter 4? Not necessarily. Michael? No. When velocity changes signs, or the first derivative changes signs, okay? So we're going to write this down to refresh our memory. The particle changes directions when the sign of velocity changes signs. So what you're going to do, you should be able to tweak your graph from letter A pretty quickly. This is why you want to define your functions. If I want to graph v of t, and maybe I want to call it v of x, then what I want to do from 0 to 8 is see where. Now it does have to also be where v of t is 0. So let's write that down. It's where v of t equals 0 and the particle is going to change direction. So you're going to go find where v of t hits 0 and changes signs. So I'm getting t equals 2.341 and t equals 6.127. All right, letter D. Is the speed of the particle increasing or decreasing at time t equals 7? Give a reason. So, and I didn't give you a whole lot of space here, is that here's what you need to do. You're going to go find v of 7 and a of 7. If velocity and acceleration have the same sign, then the particle is speeding up, or the speed is increasing. If velocity and acceleration have the opposite signs, then the particle is slowing down, or the speed is decreasing. So, if you have defined v of t, you can now, on a blank page, do v of 7, and I got negative 10.912. And then do you remember when you press menu, you can do derivative at a point or derivative at a value? Then you could do v prime of 7 for the acceleration. So the better you are at your calculator functions, the easier your life is. I got negative 10.561. So the speed of the particle is what? Is it increasing or decreasing? Is increasing. At time t equals 7, because v of 7 and a of 7 have the same sign. right, if you scroll, I have a bunch of things that we have really done before. I think there's really only one or two things that might be new on here. Initial position usually means at time t equals 0. We often know initial position, s of 0, initial velocity, v of 0, or the initial acceleration, a of 0. Particle is at position s equals s sub 1 at time t equals t sub 1. Particle at rest. This means the velocity is 0. Particle moves to the right, the velocity is positive. Particle moving left, I may have said the wrong word. Particle moves to the right when the velocity is positive. Particle moves left when the velocity is negative. So now let's connect this to what we did in 8.1. Average velocity is 1 over b minus a, the integral from a to b of v of t dt. Now that's also the average rate of change, s of b minus s of a over b minus a. Instantaneous velocity is s prime of t. Acceleration is the derivative of velocity, or the second derivative of position. Velocity is increasing, means that the acceleration is positive. Velocity of particle is decreasing. Acceleration is negative. Now, the speed of the particle is the absolute value of velocity. Then here's what we just did is these next two. Speed of the particle is increasing or speeding up when velocity and acceleration have the same sign. Speed of the particle is decreasing when acceleration and velocity have opposite signs. Then here's one that I would like you to highlight. Total distance traveled over a time interval you can find by doing the integral of the absolute value of v of t dt. And then the displacement, or the net difference, is just the integral. So this is a big one that's really new for us. Then the position, this is one we just did. You have to have your initial position plus that net change in distance. Particle changes direction where the velocity is 0 and velocity changes signs. The particle is farthest to the left or right. Okay, this is going to be a big one. That means find the minimum or maximum value of s of t over an interval. So find the value of t where s prime of t, or the velocity, is 0. You'd find your critical points and consider the position of the particle. If it's a closed interval, you have to do the extreme value theorem and check the endpoints as well. All right, let's go ahead, and we won't get very far, but we'll get a little bit into example 2. It says the space shot is an amusement park ride that gently raises riders up a tower and then rapidly bounces them up and down using compressed air. The velocity of the space shot for time 0 to 14 is modeled by a piecewise linear function as shown below. T is measured in seconds and v is in feet per second. At what times, if any, does the space shot change direction? Give a reason for your answer. So this is the graph of the velocity. So take a moment and see if you can see where the space shot changes direction. Going up to down or down to up. So we would say t equals 6, 8, and 10 seconds because v of t equals 0 and v of t changes signs at each of these values of t. All right, letter B. At what times in the interval from 0 to 14 seconds is the space shot at the highest? And how high is the ride at that time? So this is really asking me for a maximum. And that's the very last thing we went over. So what you're going to want to do is you need to know where the v of t is 0, which we just did, 6, 8, and 10. And so then our candidates, because this is a closed interval, is going to go 6, 8, 0, 6, 8, 10, and 14. So how about I let, I don't know, y of t be the height of the ride. So wouldn't y of t be the integral from 0 to t of v of t dt? So I'm going to need to put 0, 6, 8, 10, and 14. The nice thing is you're starting at 0. All right, we're going to go ahead and pause there. We'll finish this tomorrow.